Let's now present the Identification tool. Click on this icon to open the Identification tool window. To load a cube in this tool, click on the Load Cubes button. If you want to use our Hyperdoc database, you need to cover the spectral range from 400 to 1,700 nanometers. In practice, as we did here, you may need two cubes that were previously registered together. Let's start by loading the first cube. This one corresponds to the VNIR range. The software automatically detects the spectral range available in your cube. Now, let's load the registered cube that matches the same sample but in another spectral range. You can see that the currently covered range is now from 400 to 1,700. This means you can use our pre-trained models, as we will see next. As in the other tools, you can choose the colors used for the false RGB image. Before classification, we need to perform binarization to separate the substrate from the inks, or pigments. To run binarization, the software first works on a grayscale image. You can choose manually which band to use to create this grayscale image. For example, this band is not very useful because one ink is not visible, so it would not be detected during binarization. Instead, you can use our automatic method to select a good band. Now, when we launch binarization, you can see that both inks are detected and assigned to the ink class. You can improve the result by adjusting the binarization parameters. You can also choose different binarization algorithms. The key parameters are the threshold, the window size, and the padding mode. By changing them, you can immediately see how the binarization result changes. Once binarization is done, we can move to the Classification tab. Here, you can run an ink classification and also a substrate classification. If you are covering the full spectral range, you can use the pre-trained models included in the application. To add a classification model, select it from this menu, then click on Add Ink Classifier. You can see that it now appears in the queue. You can add several classifiers and run them in parallel. You can now start the full classification by clicking Start All. Once processing is finished, the results appear here. By default, we display the Clean map. That's because after classification, we can clean the classification map. You can choose a cleaning level: soft cleaning, balanced cleaning, or strong cleaning. These settings adjust the filter window size, the number of iterations, and the minimum object size used for cleaning. Let's try balanced and compare the results. For one classifier, you can display both maps, the raw map on the left and the clean map on the right. You can do this for each classifier and compare them one by one. If you click Show All, a new window opens and displays all models and all maps, raw and clean, in the same view. This makes it easy to compare results between different classifiers. You can also classify the substrate. In this example, the substrate is detected as cotton linen, and you can see this information displayed in the substrate results. When you run substrate classification with FAST enabled, the software uses the mean spectrum of all substrate pixels. If you disable FAST, the software classifies the raw spectrum of each substrate pixel, then takes the majority result across all pixels. We generally recommend using FAST classification because it is much quicker and usually accurate enough. After that, when you visualize a raw or clean map, you can also overlay the classification map on the false RGB image. At the end of the workflow, you can save the results. Choose whether you want to save the raw map or the clean map and provide a base name. By default, the application combines the names of the two cubes used for fusion. You can export the results as PNG images and also save the classification maps in HDF5 format. When exporting, you select a folder because the base file name has already been defined in the tool. After exporting, you will find the saved files in that folder. Here we can see, for each model, the map saved in HDF5 and the corresponding PNG image. Saving in HDF5 is useful if you want to reload and visualize the results later. By clicking Load Map, you can load a previously saved map. It is added back into the queue, so you can visualize it exactly like a newly computed result. Now let's look at what happens when we do not cover the full range. We load a new cube. This resets the current workflow. If we load only one cube, the tool detects the available range. You can still proceed, but results may be less accurate than with the full 400 to 1700 range. We run binarization again, then go to classification. For example, let's choose KNN. I choose this one because the training phase is very fast. When I click Add Ink Classifier, a message indicates that the spectral range is smaller than the pre-trained model, so we need to train a compatible model first. We then choose a name to save it. By default, the name includes the model type and the spectral range of your cube. Now, the status indicates that the model must be trained, and then we can start. First, there is a training phase, which can be long depending on the model you choose. Then, classification is performed automatically. As you can see, when we do not cover the full range, classification is generally less robust than when we can use the full range and the database models. You can also load a model saved on your disk. In the menu, select Add from Disk, then choose a previously trained classifier. For example, we can load the model we trained earlier, select it, and add it to the list. Now we can run it again, and it will classify without training because the model has already been trained and saved. If you want to perform a very quick test on inks without analyzing the entire document, you can use a right-click to select a small region of interest inside the image. You can then launch binarization. This step is still applied to the entire cube because it is a very fast process. However, for classification, if you only want to test a new model, you can simply launch the selected classifier. In this case, the classification is performed only on the selected region. This allows you to quickly evaluate how the two inks are classified and to see which material families they belong to. It's now time to conclude the identification tool tutorial. Thank you very much, and see you soon in the next video.